Hello, I wanted to discuss how to deal with factorials and combinations on the TI84 or TI83 graphing calculators. So a factorial is represented with the notation of an exclamation point. But what it means if you say 7 factorial is you're going to do 7 times 6 times 5 all the way down until you multiply by 1. And so there's, obviously you can do that in your calculator, 7 times 6 times 5 times 4 times 3 times 2 times 1, and get the value. So when you evaluate 7 factorial, you get 5,040. And that's not too big of a deal with a number like 7. But imagine a bigger number. You might not want to sit there going one less until you get down to 1. So there is a shortcut built into the calculator where it will do that for you. So you type in the number you want to find the factorial of, and then you go to Math. You scroll over to the Probability tab, and then you select option 4, either by hitting 4 or by scrolling down to 4 and hitting Enter to select the factorial. To evaluate, you hit Enter again, same value. So again, the directions were type in your number, then hit Math, then scroll over to Probability, and then scroll down to option 4, which is the factorial. And then hit Enter to select. And I keep not being on there, 7 Math. Hit Enter to select it, and then Enter again to evaluate. So we could take something like 26 and go to Math, over to Probability, and down to Factorial, and hit Enter. And you would see that it gives you a very large number. It's actually very large because E26 means this number times 10 to the 26th power, which means you'd be moving your decimal over 10 spaces. So a very large number. You could also evaluate a weird scenario, which is 0 factorial. And the reason I say it's weird is because really you're supposed to be going from your number down to 1. Well, you can't go from 0 down to 1. So what is 0 factorial? And our calculator will actually tell us the value, and it is 1. That's just kind of an extra property. So I could take the number 12 factorial, and it would be pretty darn big there. You can see that your factorial values get very quick, very fast. Let's try something even bigger, maybe 500. And it says overflow. It is such a large number because you keep multiplying by larger and larger and larger numbers that it gets very big very quickly. So we can quit out of that. And you also see that it was an error. So it's too big for your calculator. The value does exist. It's just that your calculator doesn't have enough spaces to give you the value. All right, while we're on here, I wanted to also talk to you about combinations. So combinations are a probability and statistics concept as well. And there is a formula for finding out the number of combinations of something if you're picking a certain number of items from it. So for example, how many combinations of pizzas could you make if you were given 10 different toppings to choose from, and you were going to pick 3. That would be 10C3. The number you're picking always has to be less than or equal to the number available. You could technically go from 0 all the way up to 10. We're just going to find out how many different pizzas could I make with 3 toppings. So the way you do this is one of a couple ways. Option 1 is that there is a formula. The formula is nCr equals n factorial divided by r factorial times n minus r's factorial. So basically, we're going to be using the factorial stuff that we just talked about if we're going to be using the nCr formula, the combination of formula. You can also find the value by Pascal's triangle. And you would need to go out 10 of these. Now that's a bit much, and so there are definitely pros and cons to both of these methods. Again, your calculator can't necessarily do very large numbers very well, and going out 10 rows here, this is actually to the 0 power, 1st power, 2nd power, 3rd power, 4th, 5th, 6th, 7th, 8th, you'd have to go out pretty far, is a bit challenging. So your calculator can do it automatically. So before we do that, why don't we just take a look at maybe what this 15 is. What does that represent? So this is power of 0, 1, 2, 3, 4, 5, 6. It matches the power of your polynomial, matches that first non-1 term. And so this is 6C0, 6 items, and you're choosing 0. You have one option. Just don't pick any of the toppings. 6C1, if you have 6 toppings and you're choosing 1, you will have 6 options, just each one of those 6 toppings. If you're picking 2 of the toppings from the 6 toppings available, you will have 15 options. That's what this means. So let's go ahead and calculate 6C2 and 10C3. So again, for 6C2, you could have also done the n, which is 6 factorial, divided by r, which is 2 factorial, and then 6 minus 2 factorial. And so to do that with your calculator, you can do 6 factorial, which is under the math, over to probability, and down to option 4. And you could find the value, but again, you could also just divide by then the quantity of 2 factorial times 4 factorial. And that way it's less likely to give you an error because it gets too big with that first value. So that's kind of a shortcut, is to have the calculator do all the math. So that gave you 15. Same answer as we saw from here. So our calculator now has a shortcut for doing nCr combinations. So I type in 6, my n value. Then I will go to math, and under that probability menu, we will go down to the nCr, option 3, and select it. And then the n is the 6, and the r is, in this case, we're doing an r of 2. And so the 6 and the 2 are representing the n and the r. And then you hit enter to evaluate. And you will get 15 as well. So there are 3 ways, and the calculator is great when you're trying to find something where it would be so big to do Pascal's triangle, or a lot of extra calculations if you have to use the formula itself. So let's do 10C3, just to model it again. You'd hit 10, math, over to probability, and down to the nCr function, hit enter, put in your R value of 3 and 120. Okay, so that is a little introduction about this, and the cool thing is when the values are small, Pascal's triangle is great because you can just quickly go, you know, that's 6C0, 6C1, 6C2, that would be 6C3, 6C4, 6C5, and 6C6. And so it's quick at calculating all of those 7 values really quickly. But if you're just wanting to know a specific one, or it's too big of a value to do Pascal's triangle for, the calculator's nCr function is a great shortcut. So good luck with finding your factorials and combinations using your TI83 or 84.